So in this video, we're going to talk about right triangle trigonometry. Now, trigonometry is a big course in itself. In fact, it is its own separate course here at many high schools and at colleges. So we're just going to do the very basics of it. So you can find that trigonometry ratios in a right triangle, and you can use the trigonometry ratios to find lengths in a triangle. So when it is not a special right triangle, or we can't use the Pythagorean theorem because we don't know two lengths, we can use trigonometry ratios to find missing sine lengths of angles. There are three basic trig ratios, and you could probably see them on your calculator. There is sine, which is S-I-N-E, but we abbreviate with S-I-N, but we don't say sin, we say sine. There is cosine, which we abbreviate with C-O-S. We don't say cos, we say cosine. And then there is tangent, which is tan, and again, we don't say tan, we say tangent. These are the three basic trig ratios that are used for the whole course of trigonometry over and over again. So what do they mean? Well, the trig ratio are, we take sine of an angle. So in a triangle, there are two acute angles. So we take sine of one of the two acute angles, either this one here, angle B, or angle A. It is never sine of the right angle, or cosine of the right angle, or tangent of the right angle. So sine is a fraction, so we take sine of the angle. It is the ratio of the opposite leg, and it's their length over the length of the hypotenuse. It is that fraction will give a sine of the angle. Cosine of an angle is a different fraction, but instead of being opposite over hypotenuse, it is the adjacent leg over the hypotenuse. All right. And then tangent, our third trig ratio, is the opposite leg. Try it again. Is the opposite leg over the adjacent leg. Now, how do you know where the opposite leg is in the adjacent leg? Well, notice up here, it says the opposite leg of angle A and the adjacent leg of angle A. So here is angle A. The hypotenuse is always across from the 90-degree angle. That does not change. However, the opposite and the adjacent can switch. The opposite leg is always whatever angle you're talking about. So if I'm talking about angle A, is the one that's directly opposite of it, across from it, and the adjacent means next to, so it's the leg next to angle A. Now this would switch if I was talking about angle B. So now if I talk about angle B, the hypotenuse stays. It does not move. However, now this would no longer be adjacent, this would be the opposite. So we're just going to go OPP. And this would be of B, and then this would no longer be this would be the adjacent leg, so we abbreviate that ADJ of angle B. So again, it depends on where your angle you're talking about. Opposite there, adjacent next to. If I'm talking about A, this is opposite, that's adjacent. If I'm talking about B, this is opposite, that's adjacent. Now to help us memorize it, wonderful math teachers have come up with this saying called SOHCAHTOA. Now, SOHCAHTOA helps you memorize what the three trig ratios are. So, S stands for sine, means opposite over hypotenuse. Cosine, means adjacent over hypotenuse. And TOA means a tangent over opposite over adjacent. To help you memorize these so you're not doing just strict memorization. So let's practice. So we're going to find the sine, cosine, and tangent ratios of angle B. So this is the angle I'm talking about. Notice I don't know what angle B is. So I can use sine. I'm finding sine of angle B. Well, since this is angle B, my opposite side is 24. My hypotenuse is 30 because it's directly across from the 90, and 18 is next to the angle, so this is my adjacent. Again, this would be different if I was looking at angle A. So the sine of B. So sine is opposite over hypotenuse, which you should have above in your notes. If you did not write it down, go back and write it down. I will mark you off. Opposite length is 24 over the hypotenuse, which is 30. Alright, and you should simplify these if you can. Don't make them mixed numbers, just make them. So in these, you can simplify both of them are divisible by 3, so that is 8. 10s, actually both are divisible by 6. I can go even further. So that's 4/5. Alright, now if I want the cosine of b, which is the adjacent over the hypotenuse, the adjacent length is 18 over 30, which is 3/5. And then I want to find tangent. Oop, there should be a b here because I'm finding cosine of b. Tangent of angle b, that is opposite length over the adjacent length. The opposite length is 24. The adjacent length is 18. Which simplifies down to 4/3. Again, we're not going to make it a mixed number. We're going to leave it improper. So now let's look at the bottom one. We are looking at angle A. Alright. So if I want to find the sine, cosine, tangent of angle A, I need to identify what my sides are. This is my hypotenuse. It's across from the 90. My opposite side of A is 65. My adjacent side, what's next to A, is 72. Alright, so I'm going to find sine of A. The sine of A is 65 over 92. And I don't think that simplifies. Find cosine of A. Cosine of A is 72 over 92. Those are both even, so I can divide them out. That is 36 over 46. So if I can go one further. That is, if I divide that by 2 again, that's 18 over 23. So I could have divided by 4 at the start. And then the last one, tangent of A. Is the opposite side, 65 over 72. Again, it's a ratio, and ratios are fractions or decimals. And so these are my 3 ratios for this situation. So this side is, why do we need to know all these trig ratios? And we can use them to find actual values when we are calculating. So to do this, we need to find the values of C and D. So here is our angle that we know. Again, we do not ever use the 90-degree angle. When you get more advanced in trig, you can see why, but we always want to use the 2 acute right angles. So we have 41. Well, then we have 17 has to be our opposite. And this one has to be my hypotenuse, and then this is my adjacent. I like to help write them out to help me remember which one is which. Alright, so I have an opposite. If I want to find the adjacent, I have to think, what trig function uses the opposite and the adjacent? And hopefully you can come up with, well, that's tan. Tan uses the opposite and adjacent. So I want to take tan of 41. equals, well, tangent is the opposite over the adjacent, so that is 17 over C. Alright, so to solve this, I need to use cross multiplication. I'm going to put tan of 41 over 1. So I go 1 times 17, so I get 17 tan of 41, which is actually just a decimal, or another number. And then I'm going to have to get C by itself, so I'm going to take tan of 41 divided by tan of 41. Alright. So to calculate this out, just to actually get C, the way you're going to do it, and you need a scientific calculator to do it, so let me pull up, I'm going to pull up my graphing calculator. Get out of here. You should have a sine, cosine, and tangent button on your calculator. So I'm going to type in 17, and then I'm going to divide by the tan. Oh, let me check, make sure. Oh, yeah, I would have got a wrong answer. Okay, tan of 41. Alright, and again, tan of 41 is just a number, and I'm going to hit enter. So the length of C is 19 point, I didn't get the decimal, 19.55, so we're round to the nearest tenth, 19.6. Alright, so that is C. So now I need to find D, and I'm going to use 17 again. You always want to use your nice number, don't use your decimals because we rounded. So I have 41, I have the opposite and hypotenuse. Opposite and hypotenuse, that is, thinking about it, is sine. Alright, so we're going to use sine. Sine of 41 equals 17 over D. Again, we're going to cross multiply. So I go 1 times 17, which is 17, equals sine of 41. We're going to leave it as sine of 41 until we get to the very end, because it's a decimal. D. Divide by sine of 41. Sine of 41. Alright, so use your calculator. I'm going to type in 17 divided by sine, S-I-N, not sin, of 41 equals 25.91, so 25.9. Now, in some calculators, depending on the model, you actually have to type in the degree first, and then sine or cosine. Alright, so let's look at the bottom. So here, my angle measurement I give you, we can't use 90, is 72, which makes y the hypotenuse, because it's across from the 90. X is the opposite, and 36 is the adjacent, because it's right next to the 72. So let's do x first. We have opposite over adjacent. Oh, opposite over adjacent, that is tangent. So we're going to do tan of 72 equals x over 36. Cross multiply, I go 1 times x, which is x. And this is 36 times tan of 72. Type that in my calculator. I go 36 times tan of 72. Again, keep in mind some calculators you have to type in the angle measurement first. And I get 110.8. Now some of you might be like, whoa, that's big. And I even kind of thought. But however, this angle is way bigger than this angle. And we talked about in class how bigger angles get bigger sides. Alright, so now we got that one done. Let's move on to y. Y is the hypotenuse, and I have the adjacent hypotenuse. That is cosine. So we're going to do cosine of the angle to give us the correct ratio. Again, these are just giving us ratios, and then we actually set up the fraction ratio next to it. The cosine is 36 over y. Cross multiplying, we get y cosine of 72 equals 36. And then you're going to divide by the cosine of 72. To solve for y, and y comes out to be 36 divided by cosine 72, 116.5, which makes sense because it's bigger than the one we got because it is the hypotenuse. Alright, so last thing we need to talk about, because we're going to be doing some applications of trig functions, is what is the angle elevation, angle depression, because we'll say that in word problems. Well, an angle elevation, they both deal with a horizontal line. If I want the angle elevation, it is the angle that is formed when you have a horizontal line and it's going up. The angle depression is pretty much the exact opposite. I'm going to draw it on the other side. Is when you have a horizontal line and goes down. So in this problem, when you have stairs and height, this is an angle of elevation. And then if I wanted to figure out what the height is, that is my opposite side. And then I have my hypotenuse. So just kind of review what trig function we use. We would use sine. And I'm not going to go through this because we just went through a bunch, but you do sine of 28 equals h over 17 and solve it that way. Alright, so review. So first step, you need to know SOHCAHTOA. If you know SOHCAHTOA, it makes your life easier because you know the different trig functions. And then review angle elevation, angle depression. You set up your ratio, you solve. Reminders to do reflections, so you get credit for watching this video.